pleased to welcome you to today's webinar on the topic of electrical modernizations. My name is Thomas Dahmen and I'm one of the 3 managing directors of the Siempelkamp Logistics and Service, SLS for short. The task of our company is to provide you with the best possible after-sales service for your Siempelkamp plants. Our focus is on spare parts service, modernizations and retrofits, maintenance support, 24/7 remote service and industrial IT solutions. In this webinar, we will present to you electrical modernizations and modification options. Automation systems and process technologies symbolize the heart of industrial plants. They often have to operate for decades under harsh conditions. The demands placed on them are extremely challenging. Therefore, the life cycles of electronic components are rather short. Spares are available for short periods only. This brings electrical modernizations into focus. Just ask yourself the following questions. How high is the risk of unplanned stops of my production due to electrical failures? How energy efficient is my plant? What are my maintenance costs? Is it worth considering an investment to decrease them? Depending on your answers to these questions, an investment in modern electronics will be paid off by itself very quickly. Now I would like to give the word to my colleagues Manuel Thiesen and Thomas Drapatz. They will give you an overview of the electrical modernization we offer and the benefits they might bring to you.
Thank you, Mr. Dahmen. Hello, ladies and gentlemen. My name is Manuel Thiesen and I've been working in the field of electrical upgrades for SLS for 7 years. Welcome to today's webinar on how electrical upgrades make your plant highly available, efficient and durable. Together with my colleague Thomas Drapatz, we will explain the possibilities and advantages of these measures.
I would also like to welcome you. My name is Thomas Drapatz and we are your contact at SLS regarding electrical upgrades. During this webinar, we will demonstrate how you can use electrical modernization to increase the plant availability and energy efficiency of your plant. For this purpose, we offer different solutions which I will now briefly introduce to you. Firstly, the Interbus and SPC G9 upgrade. Secondly, the upgrade of the drive technology. Thirdly, the modernization of the visualization system. And finally, the modernization with frequency-controlled heating pumps, which is also an energy optimization.
Before we go into details, I would first like to talk about 2 aspects: discontinued products and services and plant life cycles. Both are directly related to the topic of electrical upgrades. You may already be familiar with the current phase-out sections on our website. Here we inform you about all relevant service, component and software discontinuations. Let me outline why this is so important. Because progress in digitalization is so rapid, the life cycle of electronic components is becoming shorter and shorter. Important semiconductor components, for example, are aging faster than the end product in which they are installed. The result is ever faster product discontinuations, and these phase-outs increase the risk of not being able to react in a timely and appropriate manner in the event of a shutdown. As soon as the manufacturer announces the discontinuance of one of these critical components, long-term supply is no longer guaranteed. Stocks are quickly exhausted. Alternatives cannot be found at a short notice or simply do not meet the requirements. This situation often leads to bottlenecks in the supply of spare parts, and at the same time to insufficient compatibility of replacement types. This is a problem for the plant operator. After all, plants should run as long and as profitably as possible. We will now show you how you can achieve this goal by upgrading the plant electronic. Thomas will present the first option to you, the Siempelkamp press controller of generation 9, SPC G9 for short.
Thank you, Manuel. We are about to discuss the new generation of the Siempelkamp press control, SPC. But first, we need to take a look at the conditions under which our presses are still operating today and how the SPC has developed technically. From 1984 to 1995, the control of each functional unit, whether for heating or belt control, was taken over by space-saving independent microprocessors. At that time, troubleshooting in the event of the malfunction was time-consuming and stocking all the necessary spare parts for just-in-time repair very cost-intensive. With the progress in processor technology and the ever-increasing computer power in a smaller design, Siempelkamp introduced the first SPC of generation 1 in 1995. It's a compact 19-inch design and equipment made it possible to map the full range of function of the forming line and press with only 5 CPUs. In order to meet the constantly increasing demand on our controller presses, SPC Generation 2 was introduced in 2004. Thanks to an event of more compact and effective design, all functions could be handled by just one CPU. In addition, there were no longer any mechanical rotating hard disks. Another milestone was set in visualization, as some functions were covered by the integrated web-based service and diagnostic interface. And what does it look like today? The pressure position control system has evolved enormously and is perfectly suited for harsh working environments. Siempelkamp has mastered this great technology leap by jumping to generation 9. Especially it means the passively cooled and fanless system convinced with the absence of moving parts. It is much more robust and requires less maintenance. The cooling is less susceptible to foreign objects flying around, and the natural air circulation and the cooling fins of the profile lead the warmth away from the CPU. This perfect interaction of cooling, multiplying computer power, and integrated proprietary software makes it possible to modernize previous microprocessor system as well as generation 1 and 2 systems. The focus here is on the new generation of real-time Ethernet-based field passes, Profinet and Ethernet IP. Both field passes enable the connection to existing control systems, such as Siemens S7 or Rockwell ControlLogix. The serial interbus system and associated components previously used for data transmission in generation 1 and 2 have been discontinued. Profinet now takes the place of interbus, and only minor adjustments are required to connect the new SPC G9 to the existing communication network and integrate the programs for the pressure position control. As previously mentioned, in principle, modernizations are feasible for both market leaders of control systems, namely Siemens S7 and Rockwell ControlLogix. They can be carried out in 2 steps. Step 1. If the interbus is to be preserved, one proxy per control cabinet is sufficient to connect the existing bus protocol via a field bus based on the real-time Ethernet to the SBC G9. The integrated Profinet proxy for Interbus is simply installed as a converter in the respective control cabinets and enabled an immediate and uncomplicated connection of the Interbus components to the new SBC G9 system. Due to the system side adjustment of the software X-Work, the modification and commissioning on site can be carried out in just few days. This avoids long downtimes. Step 2. If the complete Interbus communication is replaced, all system-relevant control cabinets for the forming line and press are converted to Profinet inline modules on site. In the process, the Phoenix bus couplers and inline modules are wired according to the circuit diagram, tested and configured specially for a system. This speeds up recommissioning and avoids unnecessary downtime. This is supported by the following features. The SSD mass storage used for log data storage. A modern user interface for all browser types. Many diagnostic functions for pressure, position control and other maintenance functions. And a smart solution, mobile devices can dial in directly to the system. To conclude what has been discussed so far, switching to the SBC G9 in combination with Profinet will protect your investment in machine and sensors in the long term. In addition, you minimize downtimes and create planning security for spare parts availability. Speaking of spare parts, of course, you can also get the SBC G9 as a one-to-one replacement spare part from stock. It can also be delivered directly to your plant pre-configured. I will now hand you back over to Manuel, who will give you a brief insight into the drive technology upgrades.
We already discussed the topic of discontinued products and services. This also has a strong impact on the drive technology of a plant. Here is an example. Siemens already initiated the product phase-out of the Master Drive series on October the 1st, 2010. After a phase-out period of 10 years, production of the Master Drive series was discontinued in 2020. This makes it necessary to upgrade the existing drive technology. In the course of the modification, the old Master Drive control cabinets are replaced by new drive cabinets with Siemens Dynamics modules. We know that each of our customers has their own idea of how they want to achieve their goals in this regard. That is why it is so important to offer customized solutions. Thanks to our SLS in-house design department and our expertise as an OEM, original equipment manufacturer, at the Krefeld site, we are able to tailor our solutions to your individual requirements. The new drive control cabinets are planned and designed in Krefeld and subsequently handed over to the production of our sister company ATR. A few words about ATR. ATR Industrieelektronik is considered a specialist in the manufacture of switchgear and control systems. With a production area of 3,200 square meters, ATR is one of the largest manufacturers of this type in Germany. It is certified for manufacturing according to all possible standards represented worldwide. Our switchgear and control systems are manufactured and tested in this environment, which reduces the on-site testing times on the system during commissioning. This results in several advantages for you. you receive a completely assembled and tested drive control cabinet according to the latest Siempelkamp standard. By pre-testing the control cabinet, we minimize the source of errors and thus reduce the commissioning times. After the drive upgrade, the availability of spare parts is again ensured. In this way, we have successfully rebuilt over 30 plants in the last few years. And with that, I'll hand the presentation back to Thomas, who will now tell you about the HMI.
Thank you, Manuel. HMI stands for Human-Machine Interface and refers to a dashboard that allows the user to communicate with machine, computer programs, or systems. Outdated operating systems like Windows NT or XP, which are no longer supported, have more and more vulnerabilities. This makes them potential sources of danger and welcome entry points for attack from outside. That's why your company's network security should be optimally protected in line with the time, just like your smartphone, which you probably regularly update with software. You close these security gaps by having the HMI hardware and visualization of the plant modernized. Together with our software specialist, we develop the right visualization software for each of your requirements. For Rockwell Factory Talk, Wonderware InTouch, or WinCC. And that brings up to the next topic, frequency-controlled heating pumps. Manuel?
We not only offer pure replacement products, but also optimize plants in terms of energy consumption. For good reason. Environmental regulations are becoming increasingly stricter, forcing companies to produce in a more energy efficient manner. In return, these energy-saving measures are also promoted in many countries. Frequency-controlled heating pumps fall into this category. I would like to demonstrate how you can save energy with these modification measures. In the past, old systems were equipped with powerful heating pumps. These operate at a constant speed. And because of this constant speed, the volume flow of the heating oil has always been constant. This is exactly where the savings potential for you lies. The temperature difference of the volume flow between the in- and outlet valves of the heating system is very small. This in turn means the following. We can increase the temperature difference delta T between the in- and outlet valves by reducing the volume flow of the heating oil. Let's take a quick look at the physical relationship. Translated, this means that the electrical power, or PEL, is related to the volumetric flow V to the power of 3. If we now reduce the volumetric flow by 20%, which means we only need 80% of the heating oil volumetric flow, the required electrical power is reduced by 49%. You can achieve this with our new control software. I will of course also tell you what exactly is modernized. This modernization involves optimizing the drive control of the secondary heating pumps. This means that the existing heating pumps will be equipped with frequency converters. The plant software and the HMI system will then be expanded to include the new heating control. And finally, the existing control cabinet will be replaced with a new control cabinet which has already been pre-wired and tested. This new control cabinet can be installed in just a 1-week shutdown. New circuit diagrams and cable diagrams are also part of the scope of delivery. The interfaces to the PLC are configured by Siempelkamp, and the existing visualization will be adapted to the new functions of the frequency-controlled heating pumps. Once again summarized for you. The most important advantages of the frequency-controlled heating pumps are use of the existing heating pumps. The downtime for the installation is 2 to 5 days. Savings in electrical energy are between 30 to 70%. Longer service life of moving components thanks to reduced mechanical stress. This means more profitability because you use less energy, increased plant availability because the components are conserved, more sustainability overall, and a return on investment within 1 to 2 years.
We are slowly coming to the end of today's webinar. It is time to give you another overview of the upgrades we are presented and their benefits. So, Modification 1. The Interbus and SBC G9 modification. This stands for long-term protection of machine and sensors, minimize downtimes, and guaranteeing availability of spare parts. Modification 2. The modernization of drive technology. This stands for completely pre-installed and tested drive control cabinets according to the latest Siempelkamp standard, reduced commissioning time and guaranteeing availability of spare parts. Modification 3. The modernization of the HMI. This stands for reduce susceptibility to faults, maximum protection against unauthorized access through regular software updates, adapted solution according to the latest Siempelkamp standard for the visualization Rockwell Factory Talk, Wonderware in Touch or WinCC. Modification 4. The retrofit to frequency-controlled heating pumps. This stands for energetic optimization and higher profitability due to longer life cycle and lower energy consumption. But that's not all. These upgrades to the latest technology and current safety standards can be carried out at a step-by-step digitalization. This makes it ideal for implementing them during maintenance shutdown that are planned anyway. Let me summarize. You benefit from higher system availability, greater energy efficiency, longer service life, lower maintenance cost. These also answer the questions in the beginning. State-of-the-art electronics pay for themselves. We thank you for your attention and are now at your disposal for further questions.